Howdy and welcome back. In this video, I'd like to get into in-class member initializers. There's a little bit of rationale for how I motivated this topic, at least leading up to it, with the focus on initializer list before we got into in-class member initializers, but we'll get into that here shortly. So if you recall from the previous lesson video, we said that if we have some constructor, in this case, for class A, constructor with the same name as class, no return type, it's that special function. If we go ahead and make an assignment to a data member within the body of that constructor, that is going to be an assignment to A. So at the top of this function, the value of A is going to be undefined, and it will remain undefined until we assign a value, in this case 7. So you can think about this as just that, the declaration of some variable with an undefined value, the assignment of some value to A to give it a well-defined value. And we can see here that this is a two-step process, and that, we probably prefer a true initialization of this data member so that it begins when we hit the body of the function with a well-defined value. So we're not going to prefer this method in class. Again, I think I went over this pretty motivated this pretty well as to why not to in the previous lesson video. So let's go ahead and move on to what we said to do in place of it. So instead, we said we would like A to start out with a well-defined value and for true initialization to take place. So something that looks like this. Int A is equal to 7. Well, how can we have the same effect upon initializing a data member for one of our classes? Well, in the constructor, we can use what's known as the initializer list to go ahead and provide a list of the relevant data members to which we would like to assign some value. So in this case, for the default construction of an object of type A, we're going to see here that A is going to be given the initial or starting value of 7. And this is what we want to do. And this is what we motivated you to do up until this point. But what we're going to see here is that there are kind of some problems, not problems, but perhaps redundancies involved. If we have, say, a default constructor, some number of parameterized constructors, and reusage of kind of the default values for some of the data members. So if this is not clear right now, I have some slides forthcoming that will allow me to more eloquently present it. So C++11 and in-member class initializers. So the basic idea for C++11, or I guess that came in terms of initialization of data members, is to allow a data member to be initialized where it is declared. And that would be inside its class. Before this, only static members could be initialized in this way, and C++ opened this up for non-static members as well. So a constructor can use the initializer when runtime initialization is needed. So what we're going to see here is that in-class initialization, this example here on the left, where we go ahead and provide in our declaration of data member A, an initializer to say that A will start out with 7. This is going to be equivalent, at least in this specific context, of writing the following: providing a declaration of A, data member A, without an initializer, and then having the constructor go ahead and initialize that data member with the numerical value of 7. So far, so good. What we've effectively initialized to this point is that both in-class member initialization as well as initialization of data members through the initializer list of a constructor both perform true and true initialization. So I hope we're all on the same page at this point. Let's go ahead and move into some additional considerations here. So where the real benefits of this is going to begin to shine, the in-class member initialization that we're introducing here, is when we have multiple constructors. And why is that the case? Is because often all constructors will use, or some constructor, or subset of constructor will use a common initializer for some sort of member. So I'll go ahead and acknowledge that this slide and some of the additional slides are taken the examples, at least in some of the text, from Bjarne Stroustrup, the original implementer of the languages, C++11 frequently asked questions page. The citation is shown here. But let's go ahead and look at this example that Professor Streetstra provides. So we have some class A, and what this is doing, no need to worry about it, but we can see here there's 3 constructors. 2 are going to be parameterized constructors. One typo in one of those. I'll go ahead and put that bracket there. And then we have 2 public data members, both are typed integer AB. And then we can see here there is some user-defined type to specify data member hash algorithm. And then we also see S, which is going to be a standard library string and hash algorithm, and S will be private data members of the user-defined type A. So if we go ahead and look at our constructors, we can see here we're properly using the initializer list. There's some redundancy here. So if you look at, say, S, we can see in pretty much each of the 3 constructors, S is initialized with the same value. Likewise, we can see here that hash algorithm is starting out with the same value across all of the constructors. Moreover, if we look here at B, we can see that B in 2 of the constructors takes the same value. We can see that A in 2 other constructors takes the same value. And what we're going to see here is that by using a combination of the initializer list and in-class member initialization, we can go ahead and refactor out this commonality and set up a way that can say effectively if a data member is not provided an initializer within the initializer list, we'll go ahead and defer to the in-class member initialization. So the fact that hash algorithm and S each have a single default is lost in the mess of code and could easily become problematic during maintenance. Why? Well, if you look at here, and you're making some update, let's say we change the hash algorithm to something else, there's 3 places where we need to go ahead and make that update. Same with the starting value of S. If we wanted S to maintain a string that was something other than constructor run, well, look, there's 3 places to make that update. And the more places we have to make that change, the more likelihood that we'll miss something and an error will be introduced. So what we can do is we can factor out the initialization of the data members. So we can go ahead and provide a in-class initialization of hash algorithm with MD5 and S with constructor run. Now, the great thing here is that when this object is being created, for the data member, it is not present in the initializer list, it will go ahead and defer to the starting value provided in the class definition. So in this case, if the default constructor or either parameterized constructor is fired off to create an object of type A, we can see here that in all 3 cases, hash algorithm and S do not appear in the initializer list. So instead, they will start out with MD5 and constructor run, respectively. One thing to point out here is that if you have a user-defined type, so think a standard library string, standard library vector, some type that you've created, if you were to just have, let me see, std string S2 as a data member, so that's going to be inside our class. If S2 is not initialized with a value in the initializer list of the constructor that was invoked, in this case, since it's not a primitive type, the default constructor for S2 will fire off here, and S2 will start out as an empty string. So that's important to note for user-defined types. For the primitive types, if a value is not specified as stated before, what it starts out with is undefined. So if a member is initialized by both an in-class initializer and a constructor, only the constructor's initialization is going to be done. It will go ahead and override the default. So what we can do is we can go ahead and simplify this further. We can say, as we kind of refactored out, that it looks like in this case, A has a good starting value of 7. It seems to be reused here in 2 of the 3 constructors. And likewise, B looks like a well-defined value. Starting value would be 5. So what we can go ahead and do is provide in-class member initialization for A as 7, B is 5. And then if we go ahead and look at our constructors, the initialization list is actually cleaned up quite further. So in this case, we have 3 constructors. We have a default constructor, which is simply going to use the in-class member initialization that's specified within our class definition. The parameterized constructors are going to go ahead and in their initializer list, specify the values for which we'd like to override. So that parameterized constructor that took an integer as its argument is going to go ahead and specify that A should receive a value as its starting value, and that will override this. So A, in that context of that parameterized constructor being invoked, A will take on a value and not 7 because of the override. Likewise for B here, where B is going to be initialized with the return result of function G invoked on D there, and that would override the 5. So hopefully this is making sense so far. Again, the key here is to recognize that if a member is initialized by both an in-class initializer and a constructor, only the constructor's initialization is done. Again, for emphasis, it overrides the default. So again, here's some reference on this. Strustrip goes ahead and has some additional references to this, but this is where the example was derived and kind of the step forward of this. And this will be kind of the approach we're going to favor in this class. We're going to go ahead and perform in-class member initialization where feasible and where sensible, and then we'll go ahead and really clean up those parameterized constructors or otherwise to kind of have as clean of a initializer list as possible. So with that, adieu. I'll see you later.